Alright, so what is the domain and range of y equals ln x? So the domain is defined as all values of x where f of x is defined. So where all values of x is defined. So what that means that it doesn't go to infinity, it doesn't make a undefined number, it doesn't make a complex number, I guess. So that's what a domain is. That's all the valid values of x where f of x is defined. Okay, so the range of a function is all values of f of x that are mapped to x. Okay, so if we were to think about it, here's our pool of x values that are valid. So our function, let's say f, takes our domain values and plugs it into our range values. So this is our range, and this is our domain. Okay. So a neat thing about this is that the f of inverse helps to reverse this. So now if we use f of inverse, this becomes the domain of f of inverse, and this becomes the range of f of inverse. Okay, so one way that we can find the range of our function is to find the inverse function and find its domain, because the domain of our inverse function is equivalent to the range of our actual function. And we're going to use this technique to find the range of our function y equals ln x. Okay, so let's do this specific example. So the nature of y equals ln x, so when we're talking about its domain, is that all the values of x that make f of x defined are y defined. Okay, so the natural property of a logarithm is that the argument within the logarithm itself has to be positive. And this is the nature of the base, and how the base can never be converted to a negative number. Okay, so especially since our base is a positive number here, another way to write y equals ln x is by writing e to the power of y equals x. So we know that y will always need to be, x needs to always be positive, because e can never be is a positive number, and any positive number to any power will always output a positive number. Okay, so we know, and we reason by the nature of our function, that x always has to be greater than 0. Okay, it has to be a positive number. Okay. So what about our range? Okay, I'm going to write the domain as this too. Okay. So what about our range? Okay, so we're going to take the inverse function, which I already made here. So y inverse is actually, if we apply e to both sides, is e to the power of y equals x. Okay, so what is the domain of this function here? Well, the domain of this function is that x can be any, or y can be any of the real numbers. Okay, so x belongs to the real number set, or sorry, y belongs to the real number set. Okay, so y belongs to the real number set. Therefore, if we were to transform this back to our actual function here, the range, according to our principle here, will be that y belongs to the real number set. Okay, it could be negative infinity, it could be positive infinity. So that means that it's from negative infinity to positive infinity. All right, and we solve the range by finding the domain of this inverse function, right? So we notice that y can be any number, negative, positive, decimals, it can be anything, right? And because of that, we found the domain. When we switched it back to the actual function, the range is also the same as the domain, right? So I guess another way you guys can do this is that you can graph this function and you can visually identify what the domain is, right? And you can visually identify what the range is. But this is another way of doing it without graphing it out. And we use a lot of reason and this principle of f inverse to find our range and domain. So this solution is correct. Okay.